Hey everyone, today we're going to tackle a skill that's just absolutely crucial in our data-driven world: how to turn a pile of numbers into an actual story. We'll explore how a few simple plots can transform a sea of data into something you can actually understand, and we'll do it by looking at three essential tools.
So picture this. You're staring at a spreadsheet just packed with numbers, right? Columns and rows as far as the eye can see. It might be totally accurate, but let's be honest, right now it's just noise. How do you get from that wall of text to a real insight? How do you find the story that the data is trying to tell you?
Well, the answer is to make it visual. That's the key. Graphical representations are how we transform all that chaos into pure clarity. Today, we're going to focus on three amazing statistical tools that do exactly that: histograms, box plots, and scatter plots. Each one tells a different and very important part of the story. Okay, first up, before we can summarize anything or find any cool relationships, we have to understand the fundamental shape of our data. And for that job, our go-to tool is the histogram.
Think of a histogram as a way of sorting your data into buckets, or what we call bins. Each bar you see represents a range of values, and the height of that bar tells you exactly how many of your data points fall into that specific range. It's a fantastic way to instantly see where your data is clustered together and how it's all spread out.
Now, a really quick but super crucial point: a histogram is not a bar chart. I know they look similar, but they do totally different jobs. A bar chart compares separate things like sales for apples versus oranges, so the bars have gaps between them. But a histogram, it shows the distribution of continuous data, like people's heights. So the bars represent connected ranges, and that's why they're always touching.
Okay, so we've got a shape. Great, but what is that shape actually telling us? Well, the overall form of the histogram gives us immediate, really powerful clues about our data, especially about something called skewness. We're basically looking to see if the data is nice and balanced or if it's being pulled in one direction or the other. So let's break down the three main shapes that you're probably going to see. First, we have the classic symmetric distribution. You've probably heard it called a bell curve. Here, the data is spread out perfectly evenly around a central point. And in this perfect world, the mean, median, and mode are all pretty much the same. It's a nice balanced picture.
But things get way more interesting when the data is unbalanced. This is a right skewed distribution. See that long tail stretching out to the right? That tells you that most of your data points are clustered over on the left, but you've got a few really high-value outliers that are literally pulling the average, the mean, over to the right. Because of that, the mean ends up being bigger than the median.
And, as you might guess, the exact opposite is true for a left skewed distribution. This time, the tail stretches out to the left. Most of the data is piled up on the right side, but a few unusually low values are dragging that mean down. In this case, the median is going to be greater than the mean. Seeing this shape is an instant clue to go looking for some low-end outliers.
So, a histogram gives us the big picture, the overall shape. But what if you just need a quick, concise summary of the key stats? Well, that brings us to our next tool, the box plot.
I love the box plot because it is just so efficient. It packs an entire 5-number statistical summary into one simple, powerful image. It lets you quickly grasp the spread and the center of your data in just a glance.
The heart of the box plot is, well, the box itself. This box represents something called the interquartile range, or IQR. And what that means is it shows you where the middle 50% of your data lives. It's the central chunk of your data set after you've set aside the extremes.
So let's break it down real quick. The plot shows you the minimum value, the first quartile, the median, the third quartile, and the maximum value. But its most powerful feature, the thing that makes it so special, is how it handles data that doesn't quite fit in.
You'll notice these lines, often called whiskers, that extend out from the box. They show you the expected range of the data. But what about those little dots, the data points that fall way, way outside of those whiskers?
They are outliers. And this, right here, is the real superpower of a box plot. It is specifically designed to make these unusual data points, the anomalies, the errors, the exceptions, visually just pop right out at you. So if you need to find the strange values in your data, the box plot is your best friend.
All right, so we've looked at the shape and the summary of a single set of data, but you know, data is often most interesting when we see how different things relate to each other, and this brings us to our third and final tool, the scatter plot.
A scatter plot helps us answer a really fundamental question. When one variable changes, what happens to another one? Is there a connection? For example, as our advertising spending goes up, do sales also go up?
A scatter plot is the perfect way to visualize that.
When we plot these two variables against each other, we're looking for a pattern, and we call that pattern correlation. Generally, we're going to see one of three types of relationships pop up.
With a positive correlation, the pattern of dots goes up and to the right. As one thing increases, the other one tends to increase too. Makes sense. With negative correlation, the pattern slopes downwards. As one variable goes up, the other one tends to go down. It's an inverse relationship.
And then sometimes, the plot looks like someone just sneezed dots all over the page. It's just a random scattering of points with no clear direction at all. This means there's no correlation. The two variables seem to have no relationship whatsoever.
So we've covered three incredibly powerful tools. But how do you know which one to use for the job? Let's wrap up with a simple guide to help you choose the right plot for your question.
Here it is, your quick cheat sheet. If you want to understand the shape and spread of a single variable, you ask, how is my data spread out? And you use a histogram. If you need a fast statistical summary and you want to spot outliers, you ask, what are the key stats and are there any odd ones out? And you grab a box plot. And if you want to see if two variables are connected, you ask, are these two things related? And the scatter plot is what you need.
Look, data is everywhere. And with these fundamental tools, you are now equipped to go way beyond the raw numbers and find the real story hiding inside. So, the only question left is, what story are you going to uncover first?